Hi, I'm Yeonjung Lee, a PhD student at National University of Singapore. Today I'm going to present my research on improving IDE code inspections with tree automata. IDEs are equipped with various features to help developers be more productive and write better code. But these features are not always accurate or convenient to use. In particular, code inspections that perform data flow analysis to detect abnormal code may issue warnings even when the code is correct and written in a way that the developers intend to. And that is because the data flow analysis does not filter out the cases where warnings are unnecessary or undesirable. As shown in this screenshot, for example, several unnecessary warnings are issued by the data flow analysis, such as condition not B is always true in the second branch condition. Existing methods to suppress these bogus warnings are either too conservative or not sustainable. Conservative in a sense that when IDEs allow developers to suppress warnings by unclicking the categories here, this results in a suppression of a whole class of warnings of the same type in the entire code base. So this is not a good solution. So what a developer can do to prevent bogus warnings only in the code containing a specific pattern is to go to the IDE source code and add a set of heuristics on top of the existing data flow analysis. However, this method is labor-intensive, inefficient, and thus unsustainable for most IDE users. To address this concern, we propose a programming by example framework that synthesizes tree automata to automatically suppress bogus warnings through pattern recognition. Let's look at how the approach works. When a user notices any unnecessary warnings, he or she highlights the code segment. Then the user is asked to perform some simple drag and drop operations to specify the generalizable parts of the code with ellipses. Next, the code segment goes through an abstraction process to collect the parts relevant for pattern recognition and abstracting relevant concrete parts into meta variables. Parts of the code collected from the abstraction are then combined together to generate a tree regular expression. The generated tree regular expressions are subsequently compiled to tree automata. And finally, the synthesized tree automata are integrated into IDE code inspections. We have evaluated our idea by building a prototype of the framework that takes 3 different examples. The results show that real-life code patterns can be mechanically translated to tree automata, successfully accepting tree structure code that contains any patterns in the examples.